from the previous Victoria's Mira's presentation, 41% energy consumption, and also the hot water, 20%. That's their bigger percentage, right? Almost 60-some percentage. So the space heating and also the hot water is important. So thermal is a very big portion of our need, in addition to the electricities. So my student Bradley helped develop this PPT a lot. We jointly developed an overview of these thermal technologies. So we kind of have all these intuitive questions. What are solar thermal? I think most of you, since you're green guru, and you all know this. But why we go thermals? Why we don't see so many thermals on this, on the residential homes, and how effective they are? Is it feasible now in today's marketing? And how much they are cost? Are they cost effective? How do you choose that? We have all this question. I will see how many questions we can answer through this PPT. And so basically, solar, instead of we use solar energy directly for space heating, and also heating hot waters. So it's a direct use of solar sun power for space heating and hot waters. Why we use solar thermals? And this energy conservation efficiency actually is way high. You see that 70 to 90%. And the solar PV is a technology developing, changing, improving, but still in the 10 to 20% range. So look at that. That's, and also the payback period. A lot of times we see this large PV array, but solar space heating, solar for hot water, actually the system is way simple. You can build a very simple systems. So the payback period is much, much shorter. When we try to develop any technology, the advancement is one factors, but the feasibility, the economic feasibility, the payback periods, a lot of times affect our homeowners' decisions. And with all this solar, we talk about this about 60% energy for home space heating, hot waters. If you have the system, that can definitely offset your cost for that, and that will save your electricity, either electricity or gas burning, and that's all carbon emission involved. So that's So today we just try to go through the fundamental, the solar heating, and then the passive solar. I think through our previous presentation, we already already reviewed that a lot. It's most a simple, direct way to use the solar energies, and then maybe we'll focus on this active solar thermal systems, see how that, what it looks like, what kind of application there, product there, and what kind of OSU research we try to conduct to improve the application of the solar thermal systems. I think this is all fundamentals. The solar system, natural, we have the sun power, radiation to the surface with this power density. We all know that fundamentals. A big portion of the solar light, solar energy get reflected, get diffused to by the atmosphere, by the dust, but we still receive a big portion of sun powers, and that can be used. The way this, the sunlight, you can directly hit your surface, and also can be scattered by the dust or by the cloud, then give you this indirect diffusion radiations. So that's just kind of the fundamental part. How this will affect our energy. So this is a kind of quick equation calculating. So calculate how much energy you receive on the a surface on the ground. This is the angle, solar instance angles, and then the total energy we received will be, the energy density. We call it direct normal density. If you don't tilt your surface correct, you have angle, so you receive a portion of that, and then also you receive the diffusion radiation from other diffusion sunlight. Diffusion energy, and also you have the reflected radiation from other surface nearby you. So that's all that will affect how much energy you receive on the surface. This picture gives you a further, this, if you assume this is a solar thermal or your PV, collectors, that's all applies. And we have different angles, sun incidence angles, and then also your angle, your tilting angle of the plate. And so what is the optimum tilting angles? Betas. So that ideally should equal to your latitude. Depends on the position you're on the Earth. For Ohio, that's about 40 degrees. And then for winter and summer, you adjust that 15 degree to maximally receive sun powers. That's just a simple guidance. Solar system, we have this natural, it's a forever there power almost. And two basic system, passive and actives. I think from mirrors from Victoria's PPT, we see this picture a lot. So if you have south-facing windows, transparent, and the sunlight will naturally go in, will hit your room. If you have some heat storage, concrete, bed, or other thermal storage material that will absorb the sun power, then will release the heat energy in the later times. And then we talk about this overhang, 2 feet, 2.5 feet, and naturally sunlight, that could prevent the sunlight in the summer and also still receive the sunlight in summer. So that's kind of quick review. There's a couple schematic on the setting of this passive solar systems, and basically, it's just always very simple. Actually, the solar thermal system is very simple. You have this transparent receiving the sunlight. You have thermal mass storage. Then you circulate your heated air with your room. Okay, and then the active system. What do we have? And then we normally for the active system, we talk about we have pump. We have mechanical parts involved in this collection of the solar thermal power. So that's what we call active systems. Normally you have a fluid. You heat the fluid. The fluid will have a heat exchange either with your hot water or you heat your space. So basically use mechanical systems and to collect the thermal energies. There's a typical 3 type of this active solar device. One is called the flat plate collectors. It's kind of simple here. It looks like insulated box. You have this this like heat absorption. Normally painted into black, maybe made of aluminum, any type of material. Then you have this tube, have this hot. Have the fluid going through that, transfer the heat away to your heat exchanger, or if it's air, maybe directly circulating with your room. And we see a lot of pictures on the roof of that. This system can heat your liquid or air at temperature less than 180 degree Fs. Another one is called integrated collector storage systems. And it's a similar, but this tubing the heat tube is much larger, and it collects heat and also sometimes can store the heat. And then all this we working on. I think a previous speaker talked about is all this hot solar thermal collector system. Sometimes in wintertime it don't work that well, but it still collects a significant amount of energies. Another type of the solar thermal system is called evacuated tube solar collectors. So with this solar collector, you have there's two layer of tube. The first, it's kind of transparent glass, or what is the material looks like? It's mostly glass tubes. And then inside, you have the heat pipes. There's a little what I call a fan type of the material attached to the small tube. It will absorb more heat, get it transferred to the inside of the liquid, And this system is most efficient, but it's more expensive. And yeah, always you have the trade-offs between your cost and or the energy you harvest. So it's a vacuum space in the external tube. It will decrease. Use that to decrease the heat loss from the tubes. And this rounded shape will increase efficiency too. This is the system we see a lot actually in the commercial product. So there's about these 3 type of systems. How we apply this kind of system, this kind of schematic, come from different web resource to see. Normally you have hot, plate system installed on roof. You have water tank, in your basement, and then or you have sometimes you directly, involve the liquid exchange with your room and with your hot water. Sometimes you indirectly, you have a media fluid get heated through a heat exchanger, heat your hot water in your water tank, or heat your air in your space. And then the storage, we talk about this battery for electricity storage. It will be in the trend in the future, because the solar energy is very distributed. If it's a vast majority, but it is very distributed. Then if you try to use the solar energy through a central grid system, still I think we better use that more in a distributed way. For us doing that, I think battery is a key. Same thing for the solar thermal system. The heat storage, later will be a very interesting area to develop. Traditionally, we have this, you have water, you have this building thermal mass to store that, but now there's a phase-changing type of material, can actually store your extra heat and then release that in the evening hours. And we have that installed in core, but unfortunately we cannot see it. It's in the little roofing attic areas. That's another schematic showing in a house how this tubing, this piping working integrated with your hot water tankers in the basement. The application cost, after we see this, and we're kind of wondering how much it would cost that. So it's very based on different type of system. We see the 3 type of the thermal collector plate in this all the way into the evacuated tubing systems. So the roughly estimation is 1 gallon of hot water. You need like 1 square feet of the collector areas. And then there's, I think Eric reviewed this. So is this that in state incentives still include the, because you said solar system still receive that 30% tax rebate, right? So solar for thermal should be included that too, right? Yes. So you still have incentive to encourage you to apply this kind of systems. This is some kind of cost. We kind of search through the internet, and the cost actually you can see vary from, it's negative. Obviously, there's more tax, incentive credit going on this installation of systems, then all the way to the positive, like $7,000. When I travel to China, I think people talk about this, this year or this month, China surpassed, become this #1 PV system. But I saw a lot solar thermal system in China. If you look at the roof of the apartment on top, you see everywhere they have the solar hot water systems. And then in China, it's about 2,000 RMB per family install this small system. Come here, I see the typical price, couple thousand, 3,000, 5,000 American dollars. So I think there's large space to reduce the cost of the systems. So it obviously vary. This is another example of the cost of the collection systems. See then that's have the different specs, and there's also talk about the payback period, like 9 year, 10 years. I think this is in the higher end of the cost system. If you think about $7,000, obviously, like I said, this system still, I don't see, a vast a majority application here, and the product is limited. The price varied. This is an example of, cost example, solar and the wind. We got this from the solar and the wind in the Ohio website. Look at that. There's 3 solar thermal heating systems, and for different. That's the product they're offering for number of people. 2 people house, 4 people house, 6 people house, and this is the capacity of the solar system. And then they have all the cost, like $8,000, $9,000, almost always way to $10,000. So that's water heating, and also for the solar thermal air, water heating system together, their cost is also in this. I think this is in the high end, almost the $10,000 for this. This is some example of this solar. This is PV, and we can look at this is the solar hot thermal collection systems, and some of this solar collection systems. This cost all in the 10,000 range. Yeah, this is an example of product, solar hot air, the thermal collection, black plate. But this looks like the dimension is 400 square feet. And that's the capacity of this equipment, the facility. Then they have this cost about $1,300. That's example product. This is another example product. So this is a 2-pack, and have the 1,500 square feet, and then the cost is about $3,000. That's another example, hot water collectors, and this price is about $1,200, and free shipping. That's good for, let's see how many people is here. It's 30 tube. That's evacuator tube systems, and I assume that should be good for one household, and average 4 peoples. That's just an example of a costing of different systems, give you a sense. Originally, we thought we can contact some manufacturer, come here for the exhibit and talk more. I think next year maybe we can connect with more of the manufacturers. Yeah, just some more examples. There's a water tank, thermal storage, and vary from $1,500 to $2,100. OSU research. I think you just tour the solar in-course. I don't know if you noticed this system. This is a hot, solar thermal system. Just a solar plate to collect hot air, just to heat the hot air. And the size of this is it's about 4 feet. It's not quite 6 feet yet, but this small solar hot air system is alone. It can offset about 10% heating load of this in-core house, and also about 9% of cooling load. How that works? Initially, this installed for 2 purposes. For in the wintertime, you directly, the sunlight strike on this black, surface. The air get heated if you circulate with the room. Obviously, we have a phase-changing material here, and can store the heat, release the heat in the night hours. This can store about 30-hour worth of heating need. And in the wintertime, that's wintertime for heating. In the summertime, I think innovatively we use this solar power for moisture, for this moisture control. Because in summertime, for this low load home, it's quite common. We have the difficulty to control the moisture, the relative humidity, because your air circulation, because your low load, the air conditioning system is not a kick on very often. So then you have the moisture problem. Then we use this desiccant wheel dehumidifier. Then the hot air will, after heated through this plate, will go through this desiccant wheel. It will remove all the moisture of the desiccant, and then then they turn to the inside air. The inside air will circulate through the desiccant. The moisture will get absorbed by the desiccant. So that's a good system. I think we will work with students, try to test the capacity of performance with this small system. And also we try to develop this grant to further develop a solar-powered or using natural resource to condition the space. This is the heating and the dehumidification, and then we'll have sensor control, monitor the inside-outside condition to adding some humidification in wintertime. You do need that because it's very low relative humidity. And then also through the system, also we can do the night, ventilation cooling in summer times. That, it's by literature side, it's a very effective way to offset your cooling load too. So this is a research area we're very interested, and only this 4x6 about area can offset 10% of heating or cooling load. And then we have more space than that 4x6 area, right? So if you distribute this kind of system along the house, even on the south-facing side, I think we can significantly reduce the heating and the cooling load of this, this type of homes. Yeah, that's what I tried to, in summary, I think the solar system now is very effective and it can directly translate the sun power into the space heating and the water heatings. However, I think maybe the product, the cost seems not that high, but in terms of, in the US, I see the price is way high than the system in China. So maybe in the future, the cost can be more reduced, and then it can be more cost effective. And I'm eager to see more and more application of this. If you still remember, we need like 40% energy for space heating, 20% energy for water heating. So I think this is a great area to think about it. Okay.